Hey everyone, welcome back to Real World Vue 3 function refs. And in this series, we're taking a look at function ref composables in Vue and how to apply this cool but very niche technology to solve actual real world problems. And so for today's episode, I'm kind of excited because it is the problem that we're solving today is the one that sort of inspired me to make this whole series. It was the first one that I kind of formulated in my mind as a good example of how to do this stuff. So what we're looking at today is taking a scroll-based carousel and giving it a little bit more programmatic control. And so let's unpack that a little bit. So a scroll-based carousel, when you are adding a carousel to a marketing page or something, you have a few different options for how to do that carousel. One, you could bring in some sort of third-party dependency that does a scroll-based carousel, does a carousel for you. Most of the time, under the hood, that's going to be a JavaScript-based carousel. So it's going to be using JavaScript to do these kind of transitions and animations, moving slides out of Vue and bringing the next one into Vue, taking control of this little effect you see where like you can't stop in the middle of two slides. It'll always snap one of them into position. So you could do that with a third-party dependency. You could do that with your own implementation, writing your own JavaScript with an animation library to do this stuff. Both of those options I think are not ideal because third-party dependencies, I don't know, for something like this where it's not a huge value add in terms of like business value add to your app, it's more of just a smaller feature of what will probably be a larger marketing page. I don't love the idea of bringing in third-party dependencies, possibly increasing the size of the app just to accomplish those small tasks. Definitely wouldn't recommend doing this on your own, implementing this from scratch in JavaScript, just because this kind of animation and transition code is exactly the kind of thing that gets really complex really quickly. And it's just, again, thinking of this carousel as part of a larger marketing page in the larger scheme of things, it's just not smart or efficient to spend all of that time and energy optimizing these tiny little pieces when you need to be spending your time and energy elsewhere on things that will have hopefully a larger impact on your project or your business or whatever you might be working on. So that leaves us with the third option, which is to implement the carousel using CSS Scroll Snap features, which is such an awesome way to do this kind of thing. And that's how I've done it here. I have used in my template, you can see, I've got a root element here containing the carousel, and then I'm rendering using v4 a list of carousel slides, and I'm using Tailwind CSS Scroll Snap utilities. So I've got overflow scroll, snap X, snap mandatory on the container, and then I have snap center on the individual carousel slides. And just those two things working together give me this super nice, super smooth carousel effect, all based on scrolling. And I don't have to write any JavaScript at all to get this working. The downside, of course, is that things that you would normally get built, kind of baked in with a JavaScript implementation, like previous to next buttons and having a number that helps you keep track of what slide you're currently on, that kind of stuff is just you just don't get it with a CSS-based carousel. We have to do some extra work to implement that. But I think, as we'll see in this video, implementing that kind of stuff, there's a way to do it with a function ref composable that is pretty straightforward, definitely way more straightforward than swapping this out for a JS-based carousel that you either have to write on your own or find some trustworthy third party that can do it for you or any of that kind of stuff. So I think writing the function ref composable to add these small additional features is going to be a more minimalist and more straightforward and more ideal solution for most projects that need a carousel. So let's dive right in. You may have noticed looking at this template that I already have some function refs bound to a few of these elements. So I've already created them. I have a use scroll carousel state composable that we're going to work on. And I already, just to save a little time, created the container element API using this use element API function that we've been using throughout the series. And then I created the slides API, which is the one that we're going to use to get access to each individual slide in the carousel. And then in the template, for the containing element, I have :ref equals container.ref. This is a function ref specifically for the container element. And then in the v4 rendered list of carousel slides, I also have a ref bound. And for this one, I'm using slides.getRef, which if you've seen any other episodes in this series, you might remember is this getRef thing is a function ref getter. We pass in the index of the current element. So basically what happens is v4 renders over each item in our array. And then for each of those items, it calls this getRef function and passes in the index, and it retrieves the function ref that is supposed to be bound to that particular element. And the end result is that in our scroll carousel state composable, we have slides dot elements dot value, which you can see from type checking here is an array of HTML elements. And as soon as a component is mounted, we'll be able to access this array of elements, and it will give us access to each one of our carousel slide elements here. So that is all the setup work, and then we can kind of dive right into the functionality. So the way that I like to approach these kinds of things, and I have used this same approach with tab lists and list boxes and any kind of thing like this where you're rendering a list of items and you kind of need to know like which item is currently focused or currently selected or whatever. My favorite way to do that, and the way that I find is easiest to reason about, is just to maintain a simple number, a simple reactive number. So we would do something like const index of visible equals ref 0, and we should import ref from Vue. And the idea is that this index of visible would tell us at any point in time what's the index, meaning like the index position in the slides array, what's the index of the currently visible element, and then we'd be able to do simple arithmetic on that index, like add 1 to it or subtract 1 from it to change which element is currently visible. So let's implement the one half of it, which is like we make a programmatic change to the visible index, and we want that change to be reflected in the DOM. So we want to perform a side effect when that happens, and we want these basically we want to be able to have these previous to next buttons mutate the visible index and then scroll the proper element into view when that happens. So what we can do is there's a few different ways to do this. We'll go with, I think, a simpler one for now. So we can say, we'll define the previous and next functions to get this all going. So we can say function previous, and we want to first check if the index of visible is 0. If so, in this carousel implementation, we're just going to return. You could certainly build a carousel or maybe make it optional that like going, if we're at the first item and we click previous, it loops around to the last item. For this example, we're just going to say, nothing happens when you click previous and you're already on the first slide. Otherwise, if you're not on the first slide, aka the index of 0, we would do index of visible.value, make sure I don't have typos here, and then we can just do minus minus. Next is basically the same thing. The only difference is that in our check, we say if index of visible.value is or equals the slides.elements.value.length minus 1 return. So what this is saying is if the current index of the index of the currently visible element is the same as the index of the last element in the slides array, that means that we're already on the last slide and there is no next element. So we don't want to do anything. We just want early return. Otherwise, we're going to do just the opposite. We're going to do index of visible.value plus plus. We can return previous and next from our composable. We can destructure them in the return value of the use scroll carousel state composable, previous and next, and then we can bind those functions to our buttons in our template. Right here, I just have those 2 buttons set up already. And so with this done, we actually need to, we don't want to just mutate the index, we want to scroll that element into view. So element, or we want to do slides.elements.value index of visible.value.scroll into view. And we'll do that with smooth behavior. We could make this configurable with an option. But for now, we'll just do it with smooth behavior. indent that a little bit to see it better, and we'll just copy this down into our next function as well. So now I think we should be good. Let's reload the demo, make sure we're okay. Yeah, okay, cool. So you can see that we are clicking next and previous, and they both work. They mutate the visible index, and then using that visible index, we can reach into our array of carousel slides, grab the appropriate one that is supposed to be visible, and use the scroll into view. This is just a web API that's built into every HTML element, and we can use that to actually get the element into view into our carousel. So that's pretty cool. I think before we go much further, we'll just do this other piece, which is displaying the index of the visible, like displaying which slide is currently visible. So we can do index of visible. Actually, I haven't returned it from the composable yet, and it'll be +1. So I need to return that from use carousel state, index of visible, and index of visible here as well. And now we should be good. So yeah, as we're clicking these previous to next buttons, you can see down there that little number. We're on 3 out of 10. We click next, it moves to 4 out of 10. All the way down, 7, 8, 9, and 10 out of 10 would be the last one. Okay, so now the problem is that the data isn't syncing in the opposite direction. We have a nice top-down approach where we can programmatically change the visible index, and that change will flow down into the DOM and keep the DOM in sync with what our reactive state says. But the opposite is not true yet. So if the user is scrolling this carousel on their own, instead of clicking the previous to next buttons, we are not being notified of that change, and our reactive state is not being kept in sync with the change the user is making. And so in a lot of these cases, I like to think of this. I like to have the mental model of like a V-modeled text input in my head. Where with a text input, if you put V-model on it, the idea is that you'll have a string that you control, that your app controls. And you can make changes to that string, and those changes will show up as the context of the contents of the text input, the HTML text input. Likewise, the user should be able to type things into that text input, and in doing so, they should be able to update your string in the app. So your app, the string should update whenever the user types into that text input. So the reason that works is because we can attach an onInput listener to the text input. We can say onInput, and then grab the event from the callback and say myString.value equals event.target.value. So it's as simple as that to get state from a text input reflected back into our application and keep everything in sync. With a carousel, the way we do that is a little bit more complex. There's no, there's no concept of like an on visible slide or something like that. There's no event like that. But instead, what we can do is we can set up an IntersectionObserver. And we'll get that initialized right here while I can explain what we're talking about. So const observer, we'll assert that as IntersectionObserver, and there's a few different details here to unpack. So an IntersectionObserver, the job of an IntersectionObserver is to basically call a callback function whenever an element comes into a viewport. And you can specify which elements you're observing, which elements you're tracking to see if they're visible or not. And you can also specify the viewport to say like, okay, visible, but relative to what? By default, it's relative to the document. In our case, of course, we're just concerned about the carousel. So we want to know when are the slides visible inside of the carousel container. And the IntersectionObserver is going to allow us to implement that code. So const observer, IntersectionObserver. Oh, we want that to be let, actually, first of all. Okay, yeah, so that should solve it. Then two little things here. We're going to do on mounted and on before unmount. Get this stuff set up and talk about it before we get into the meat of the callback function that IntersectionObserver is going to call for us and how that all works. So, IntersectionObserver is a web API. We don't generally want to access it in the main body of a composable outside of a mounted hook or something like that, because if whatever app is using our use scroll carousel state composable, if that app gets server-side rendered, this code would run and IntersectionObserver would not exist. I think, maybe it would be polyfilled or something in some server-side rendering setups, but to be safe, you generally don't want to interact with these web APIs at all, except until after the component is mounted. So let's import those hooks from Vue, on mounted, on before unmount. No. Unmount. Oh, I already have it imported, so. Okay, so that's why we're using onMounted, because we don't want to access IntersectionObserver. We don't want to set it up before like server-side rendering setup, so to be able to handle that. So what we will do is observer equals new IntersectionObserver. This is the constructor function for the IntersectionObserver object. It's going to accept some different stuff. We'll talk about that in just a sec. But before we do that, let's talk about this on before unmount. So in on before unmount, we're going to call observer.disconnect. And this will say, like, okay, before the component unmounts, when the component is when Vue is removing this component and all of its child elements from the DOM, disconnect the observer. And the purpose of this is to just kind of as a safety catch to avoid memory leaks. Like what I mean by that is we don't want to have a component mounting and unmounting a bunch of times, and every time it gets initialized, it creates a new intersection observer, and then it just leaves that intersection observer like hanging around in memory in the browser. Usually the browser is pretty good about cleaning that stuff up. Like if I remember correctly, I think if you have an observer, resize observer, intersection observer, whatever, and it's observing a bunch of different DOM elements. If all of those DOM elements are removed from the DOM, I'm pretty sure the browser would garbage collect the observer instance and get rid of it, so that you kind of, it like has built-in, you know, like memory leak avoidance into it, which is pretty cool. But just to be safe, I like to disconnect it. This is kind of an implementation detail-y kind of thing. Generally, I don't like to be too concerned about this stuff when I'm just trying to like work on a carousel state composable and do some cool features with it. This stuff is a little bit close to the bare metal for my preference. In my own libraries, I have a composable that will set up intersection observers for me, and inside of that composable I remember to tear them down so that I don't have to remember to clean up those side effects every single time I make a new intersection observer. But just in this example, just to keep things lightweight, we're not bringing in all those additional dependencies. So the only catch is that we have to remember before the component unmounts, we disconnect the intersection observer. This is true also if you're adding event listeners, you want to remove them before the component unmounts or anything like that. So that is the purpose of that code. And now we can get into the fun stuff, which is like wiring up this intersection observer to interact with our reactive state. So the intersection observer constructor, when you call new intersection observer, the first parameter it accepts is a callback function, which it will call whenever a new kind of intersection. They're called intersection observer entries. Whenever one of those things happens, basically whenever one of the elements we're observing changes its visibility, we get a new intersection observer entry, and this callback gets called. And the first intersection observer entry is always the most recent one. So what we want to do here with this callback, we want to get, basically what we're trying to do is figure out which element has entered our container, which element is currently visible in the container. Based on what the intersection observer is telling us. And then the next step would be, well, let's actually just do that first step first. So we want to say const, we'll destructure target out of the entries, the first entry. And if we hover over target, you can see it is an element. So that was our first step. Figure out what is the element that just entered the viewport, and that's stored right here in this target variable. Next thing we want to do is figure out where is which slide is this? What's the index of this slide relative to our other slides in our array of slides? And the way we can do that is by saying const index of target equals slides dot elements dot value dot find index L arrow function, get some indentation here, and we'll return L.isSameNode target. So this code is basically saying loop through the slides. As soon as you find the element that is the same element as our target, basically as soon as you find the target, tell me its position, its index-based position in the array. I don't think there are any cases where this would break or return undefined or anything, but just to be safe, we'll say or 0. So index of target, if something goes wrong in here, will always default back to 0, and the rest of our app won't break. Then the final step here is, now that we know which element is visible and we know its index in our array, we can say index of visible dot value equals index of target. And this is kind of the final magical piece that brings our reactive state in sync with whatever changes have happened in the browser. And so we can reload here. This won't quite be working yet because the final thing we need to do is pass in a few options as the second parameter of the IntersectionObserver constructor. So in this options object, we can set the threshold, and we'll set that to 1. And this is basically saying we don't want this callback to fire until one of the elements we're observing is 100% visible, perfectly visible inside the container. So if these slides are like halfway between, we don't want the callback to be continually firing when we're kind of in this in-between state. Once we hit a point like this where an element is 100% visible in the container, that's when we want to know, okay, which element was that? Is it, which one is currently visible, and we want to update our reactive state to match that. Then the only other thing we want to pass into the IntersectionObserver options is the root element, and that's going to be our container.element.value, which is our div that wraps around all the carousel slides. And this is saying, okay, when you're measuring whether or not an element is visible, measure that relative to this particular element. So that's saying all of this code right now, to just kind of summarize it, it's saying, okay, IntersectionObserver, when a slide enters our container element and it's 100% visible, then I want you to fire this callback. And inside of that callback, I'm going to figure out which element entered. I'm going to figure out its index in our slides array, and then I'm going to update our index of visible reactive state to match that index. And then the final piece to make this all work is we just have to make sure this observer is actually observing each one of our slide elements. So to do that, we can just do a little for loop. We can say for const slide of slides that elements dot value observer dot observe slide. And with all of that done, oops, weird autocomplete there. With all of that done, I think we should be totally good. So previous to next buttons, yep, still working, still good to go. And another little reload. I don't know, weird stack blitz stuff. And then if we scroll, you can see that the index is updating. So we're on 10. Now we are on 5, and we click next. We go to 6. So now everything is working. We've got a nice little combination here of some top-down state, index of visible, dictating which element should be visible, and then our scroll into view callbacks, implementing that change, actually making that happen, performing that side effect on the DOM. And then we're also using the IntersectionObserver to capture user input on this carousel. Anyway, long explanation, but really at the end of the day, we've got this composable, which is 58 lines, and that's kind of with pretty generous indentation. And that's all it takes to add this kind of JavaScript-y functionality to a carousel that otherwise would just be CSS-based and not really have any programmatic control over it. So a really neat way, really fun problem to solve with function refs. I'm a really big fan of this because carousels have their own limitations. There's plenty of research out there to suggest that it's not a super effective way of delivering content. Like, people rarely scroll through these things and actually look at every single slide. At the same time, though, it's, kind of a landmark UI feature. It just adds a level of polish and finish to a marketing page, and it looks great. So the ideal situation is that we can achieve that kind of professionalism and that polish without doing too much work to fiddle with JavaScript animations and all that stuff. And so today we were able to do that with CSS Scroll Snap properties and just a simple little, not simple, but fairly short little composable, function ref composable IntersectionObserver, some cool different technologies in here, and all of that working together to give us a really nice developer experience and help us ship this feature nice and quickly. without spending an unreasonable amount of time on it. So yeah, that was this episode. Scroll-based carousels, function ref composables, nice little combination, and I will see you in the next episode.